In this video, we will be solving this system of linear equation using substitution method. Of course, in our previous video, we had solved this same system of linear equation using matrix inversion method. All right, so next we try to solve the same system of linear equation using substitution method. Now, for substitution method, we simply solve for one of the variable and substitute that value and substitute that equation in the other equations. So the simplest one equation to pick here in solving for one of the variables, say x, is this equation. So we can solve for x. So x will then be equal to 6 minus y and minus z. So the next step is to substitute for x in the second and third equation. So that means instead of x here, we'll then have 2 multiplied by 6. Instead of x, we then replace x with 6 minus y minus z. Then we continue minus y plus 3z equals 14. So we also do that for where we can expand 2 multiplied by 6, 12. 2 multiplied by minus y will give us 2 minus y. Minus 2y. And 2 multiplied by minus z will give us minus 2z. So we then continue and collect like terms. So collecting like terms shows that minus 2y minus y will give us minus 3y. Then minus 2z plus 3z will give us z. That's plus z. Then we've got 12 here and 14 here. So we collect the like terms, and this comes here to become minus 12, or we can say subtract 12 from both sides. So when we simplify that, we then have minus 3y plus z equals 2. That is 14 minus 12. So then, for the next one, we also substitute this value for x in this equation. So that will be 3 into brackets 6 minus y minus z. So we also expand, combine like terms, and move on. So moving on from there, we simplify what we've got, and that will give us y minus 4z equals minus 17. So the third step now will be to solve the two variable system minus 3y plus z equals 2 that we got earlier, and y minus 4z equals minus 17. So we can first of all solve this equation for y. So you make y the subject, and we then get y equals 4z minus 17. That is when you add 4z to both sides of the equation. Minus 4z plus 4z here becomes 0, and 4z plus 4z here will come here, and you see this is minus 17, and that is placed where it belongs as appropriate. So you then again, because we are using substitution method, you can now substitute this for y in this equation, and that is what we've done here. So minus z, then you substitute this for y, and you see by so doing we can expand, collect like terms, and solve for z. So solving for z shows that z equals 49 all over 11. So then we can then substitute this value in any of these equation to get y. So of course, in order to just simply get the value of y directly, because we had already made y the subject here, we can just substitute 49 all over 11 for z here and just play around the equation just as this to get the value of